Hello and greetings. This is question number 7 of October November 2025. And this examiner has asked us to show equation 10 of x cube plus 2 tan of 2x minus 10 of x equals to 0, which may be expressed as this. So, in this particular equation, we observe that this 2x is not in this, so we can just remove this by plugging in the identity. First of all, let me just rewrite the equation as tan of x cube, tan x cube, tan cube of x plus 2, and instead of that, tan 2 of x, I'll just plug in the value minus of x equals to 0. So tan 2x can be written as, with the identity, 2 tan x over 1 minus tan square of x. Now we can just take LCM. So the denominator of that will multiply with every term, and this would be just 2 times 2, 4 tan x over this 1 minus 10 square x and minus tan of x times 1 minus tan x square of x equals to 0. This will multiply with 0, it can cancel out, you'll be left with just the numbers above. So you'll have tan of x cube minus tan power 5 of x plus 4 tan x minus tan x plus minus multiplied with this minus will give you plus, and you will have tan cube of x equals to 0. Now let's just rewrite it. We will just write as minus tan power 5 first. Then we have this can be cancelled out. No, we cannot cancel. We can add these 2 tan x. So you would have plus 2 tan cube of x. Then you would have just 4 minus 1, and you'll just be left with 3 tan equals to 0. Now this can be solved by taking a common, and you can take common as negative tan. Yes, we can take, let's take negative tan x as common. So you will be left with tan power 4 x minus 2 tan square of x and minus 3, and this would turn out to be 0, so we'll not take that value. So other value is tan of or 4 minus 2 minus 3 equals to 0, and that's what we had to show. And as tan of x was not equal to 0, so this is shown. Alright, that was part A of question number 7. And using the same equation, hence solve the equation. So this equation is same. So instead we have theta. So let me just grab this equation. All the equation is same. So if the equation is same, we'll just plug in the values. We'll have the same answer. Means we have just proved that this would be the equation. So we already found that the equation was equal to this. So, but the thing is that in that particular case we have 2 theta mentioned and we have x. So I'll just change the signs. Instead of x, I'll just have to write 2 theta everywhere. That won't make a difference because the equation was same. And the range is from 0 to pi. That will be at the end. So first of all, we can take the quadratic of this, or we can take, yes, we can take, that's a hidden quadratic equation. We can keep tan of square as common of 2 theta. But before that, we need to get the middle term break. So tan 2 theta plus minus 3 tan square of 2 theta and plus tan square of 2 theta would be equal to, now you can take common, tan square of 2 theta, you'll have only tan square of 2 theta here, and you can have just 3. Over here you can just take 1 as common, so you'll be just left with tan square of 2 theta minus 3, and the final equation would be tan square of 2 theta minus 3 times tan square 2 theta plus 1 equals to 0. Now we can keep both the values equal to 0. Tan square 2 theta minus 3 equals to 0. Other value would be tan square 2 theta plus 1 equals to 0. So this would not be possible because it would have no real roots or solutions, because it would turn out to be -1 and we can't take the root of negative number. So we would have solutions for that other number. So we would write tan square of 2 theta equals to 3, and if you take the root of this, you would have tan square of 2 theta root of this, so you have just tan 2 theta and it would have plus minus 2 roots. Now when you have 2 roots, we need to have the first basic angle. So we know that you have 4 quadrants. So there is a simple acronym that can be taken out, that add sugar to coffee. So we know that all values are positive here, sine is positive here, tan is positive here, cos is positive here, all the rest are negative. So first of all, tan, if you take 2 values here, tan 3 positive would be here, and the value for, let's take the thetas first, tan theta, but let's don't keep tan theta, we'll just have 2 theta. We don't have, first of all we have a range, we can't do that, so range has to be made same. So let's take the range here. So how to make the range same? Before starting the working, we would have as 0, we'll just multiply this with 2. So you will have the range of 0 to theta, and that would turn out to be 2 pi. So that would be our new range. And now we can just take that, first of all, 2 theta and inverse of positive cube root. This would turn out to be pi by 3. So pi by 3, this is positive. We have two quadrants where tan and all the first quadrant and the third quadrant. So this would be the positive values. Going anti-clockwise, pi by 3 here and pi by 3 on the other side. That would be the basic angle of this. In the similar way, negative tan would be negative in the second and third quadrant, so you would have either, we can make the quadrant here, or we can just make another one. Over here. So in this we will just, instead of removing all, or we can just make another one. So the other basic angle would be negative. So negative goes from this basic angle, pi by 3 and pi by 3. So when we know this, so we can have the working here. Let me just make some space here by resizing this. Okay. So calculating both, first of all, let's do the working for the positive one, 2 theta. We know the first value is this, pi by 3. And the other values means obviously it would turn out to be from here to here. So over here is pi. We need to add pi to this, pi by 3. So this would turn out to be pi by 3, and the other value would be 4 pi by 3 equals to 2 theta. But we need the value for theta, so obviously it would be multiplied. So theta over here would be pi by 6 and 4 pi by 6. So this would be the positive values, and for the other two values, I'll do the working here. We know that 2 theta of that would be tan of negative 1 was, obviously it was negative, so the basic angle was the same, even though we had to take tan inverse of negative this, but it would remain same as we see that. So over here, from here we can move from here to here. So we say that pi, we say pi minus this. The first value we can get, 230, is pi minus pi by 3, and the other value can be, which is on this side. So we know that pi, and this would be 2 pi when it comes over here. So 2 pi minus pi by 3. So other value would be 2 pi minus pi by 3. So you would have 2 theta, so this would give you 3 minus 1 is 2, so you have 2 theta by 2 pi by 3, and the other value will be 3 times 2, 6, 6 minus 1 is 5 pi by 3, and this would also give you other values. That would be 2 pi over 6 comma 5 pi by 6. So two values from here, two values from here, so we will say that theta would be equal to pi by 6, 4 pi by 6, 2 pi by 6, and 5 pi by 6. We can also simplify these two values, but that's also fine. So that was part B of question number 7. I hope it was useful. Thank you.